everyone. My name is Sivan Biham, and I am a computer vision developer and researcher at Healthy.io, and I hold a master's degree in those fields from the Weizmann Institute of Science. For the last 3 years, I am part of a team who's working on closing the gap between technology and wound care. We are developing an application for wound nurses and doctors in order to support them in their day-to-day work and help them to provide the best treatment for the patients. Before we start, I just want to say that all the wounds we are going to see today are not real wounds. Some of them are makeup wounds, like the one you can see here, but most of them are just graphic illustrations of wounds, so we can all be relaxed. For the lucky ones of you that are not familiar with chronic wounds, I will give some information. A chronic wound is defined as a wound that does not heal within 6 weeks, where it actually takes an average of 12 to 13 months to heal. There are a lot of people who suffer from chronic wounds. There is approximately 7 million people in the US alone, but there are not so many wound nurses. In average, there is only 1 wound nurse for every 500 wound patients, which means that each nurse sees a lot of patients every day, and we are here to help her. When a patient comes to the clinic, the nurse can see a visual timeline of the wound progress between different visits, something similar to what you can see here. But as you can see, it's not very easy to compare how the wound changes between different visits because the images are shown from different point of views, different orientation, and different scale. What we would like to provide the nurses is a consistent timeline like this one, where all images are shown from the same point of view, same orientation, same scale, and now it's very easy to see how the wound changes between different visits. In this case, the wounds getting smaller and better. So now let's talk about how we can do it. I guess you might ask, why not just to align the 2D images, one to the other, get the timeline, and that's it. So I want to show why in our case it will not work. So in order to match, to align 2D images one to the other, we first need to find feature points at each image, and then we need to match between those feature points to do the alignment. In our case, we have 3 types of feature points. We have feature points on the wound, but the wound is changing between different visits, so we can't use them in order to match between different visits. We have feature points on the background, but the background is also changing between different visits. One visit might be at the home of the patient and the other at the clinic, different rooms in the clinic. We can't use it either. And the last type of feature points are feature points on the body part, but those are the hardest feature points to match because the body part is very smooth and it's hard to discriminate between different feature points, so we can't use it. So we can't use the 2D images, and our solution is to instead use 3D models. We want to align 3D models of the body part and use this transformation in order to create our 2D timeline. Let's begin with the input to our solution. The input to our pipeline is information about 2 visits. The first one is what we call the reference visit, the first visit for this patient, the first image we want in our timeline. And the second visit, it's the new visit when the patient just comes to the clinic to see the nurse. For both visits, we have a video which the nurse takes using our application, where she takes a video of the wound. And for the reference visit, we also have what we call the reference frame, which is the first frame we want to put in our timeline. Our goal, given all this information, is to find a new frame from the new visit video that we will add to our timeline, that we will be able to align to the reference frame visit. Okay, so this is the overall pipeline that we use in order to create the timeline, and it consists of 3 main stages. The first one is to create the 3D models. The second one is to align them one to the other. And the last one is to go back to the 2D images, choose a new image to add to our timeline, and align it to all other images that we already have in our timeline. So let's start with the first step. Our first step is to reconstruct our 3D model using the video we get from the nurse. And as I said before, the background is changing between different visits, so we want to create a background-free model, so we will be able to align them one to the other. In order to do so, we first want to filter out the background from our images. To do it, we have a body part segmentation neural network. We pass all the frames from our videos in this network, and using the output, as you can see here, we can filter out the background from the images. For the next step, let's assume that we have an open source library that, given set of images, it reconstructs our 3D model using classical algorithms from 3D reconstruction. And in addition, for the model itself, we get also set of camera parameters and location, one camera for each frame that we use in our reconstruction, and each camera is located at the relative location between where the frame was taken and our 3D model. So we can give all of our filtered, all of our images without the background to this open source library and get the model that we want to use. Great. We have two models, one for the reference visit and one for our new visit. And now the next step is to align them one to the other. To do so, we use the classical, the popular algorithm, iterative closest point. This is an iterative algorithm, which basically at each iteration, it calculates the closest point between one model to the other model. Using these correspondences, we can calculate the transformation between those models. And by applying this transformation, we can minimize at each iteration the distance between the models. At the end of all the iteration, we hopefully will get the aligned models that we want to use. So now let's see an example. We have two models. They are cylinder-like in their shape. We input them into our ICP algorithm, and we get this output, which looks pretty good. It aligned both models. This is what we want to get. But we need to remember that those models are not just 3D models. They are representing a physical body part that we want to create a timeline. So here you can see the physical representation of those models. And you can see that maybe we thought that the output of the algorithm was good enough, but we can see here that it stretched one of the models too much. And now the proportion between those models that they are representing a real body part are incorrect. In order to fix this issue, we use what we call as calibration stickers. Those are stickers that the wound put near the wound at each visit. And they have the exact same real-world size for all the calibration stickers. So now we can detect them on the 3D models and scale a priori the models such that the calibration stickers will be in the exact same 3D size. Now, our next step will be to give our ICP algorithm the scaled models and to disable the scaled option from the ICP algorithm. As you can see here now, the output is the output that we want to get. The models are not only aligned one to the other, but also we keep the proportions for the real representations. Okay, so now the last step. All we have left to do now is to choose a new image from our video and to add it to our timeline. So to do so, we have two aligned models, and as I said before, for each model we have set of camera parameters and location. And now let's see how we can use them. We have the reference frame, and we can calculate the wound boundaries on this frame. We can take those boundaries and project it into the 3D models using the corresponding camera. The next step we can do is to take this exact same 3D points that we just projected and project it back to each frame from our new visit video. Just remember that our models aligned, so it represents the same point. And this will give us correspondences between the reference frame and each frame from our new visit video, the correspondences that we weren't able to get when we used directly the 2D images. Now, using these correspondences, we can calculate the transformation between the reference frame and each frame in our new visit video. And all we have left to do is to choose the best transformation in this set. The transformation that when we will use it, we will apply it on the corresponding frame, will result in minimal distortion for this frame. So we choose the frame, we apply the transformation on this frame, and we get the aligned frame that we want to add to our timeline. And if I will summarize what we just saw, so we combined here segmentation-based neural network algorithms and algorithms from 3D reconstruction and registration in order to provide the wound nurses a consistent timeline to support them in their work and help them to compare calibrated images between different visits so they will be able to give their patients an optimal treatment. Thank you for listening. If you have any questions, you can reach me in wherever you want.